I'm fine. Last week I was in Germany. I couldn't go over the stuff. It was very busy over there. So let's go over the final things of this lecture. And let's talk about your project a little bit. Give more description. And the program should be ready by June 22nd or so. And then we will send you the sequences for your model to test. And then you're gonna send the output of your program and also the script as well, so that we can evaluate in time to give you a project score. As a result, you should send them to your TA. So I hope by now everyone has a TA assigned and the groups are established for the project. Today, I'm gonna finish the profile matrices and what you can do with profile matrices and what kind of questions that you would get in the exam. And then we will send you the last 2 years final exams for you to prepare. And when was the final exam?
It's gonna be on the 22nd of June.
Yes. So on 21st of June, we will go over it.
Okay.
So I will send you the final exams of last 2 years today, and you should send your answers to your TAs, and then I will solve them on 21st, June 21st. Okay, profile matrices. As you know, you have the multiple alignment. From the multiple alignment, we can determine the score for each type of amino acid. Let's say these are the amino acids: position 1, position 2, position 3, position 4. What kind of information you can deduce from this? Let's say these are the scores. Position 3 is position 4 is let's say this is your profile score that you obtain from the multiple alignment of these sequences. And according to this profile matrix, which position is not important? Which position is the most variable position in this profile? Position 1, 2, 3, 4 cannot be determined. What's the answer?
Cannot be determined.
Position 1
But can't be determined.
is the most variable position. Why? Because no amino acid is preferred at that position. So how can you get like very low scores? If different types of amino acids are occurring at that position, if that position is not conserved, then their scores cancel each other out and you get a score around 0 or very low scores. So having very low scores in the profile matrix means that position is highly variable. So most likely in the alignment, you have some A's, very few B's, and some C's as well. So that's why when you have combinations of these, these positive scores and negative scores cancel out, and you get a score around 0, close to 0. That means that position is highly variable. But if you look at the second position prefers A and doesn't prefer B or Z. Third position prefers C most, but B also, because you get positive scores, but doesn't like A. And fourth position prefers Z even more, and B still positive score, but doesn't like A at all. So that means according to this, your profile is not important in the first position. It can be anything because this position is not contributing to the profile. And the second one should have an A, and the third position should have a Z or B, and the last position should be a Z or B, but most likely Z in both of the cases. Z is the first preferred amino acid. So that's the profile of this protein sequence. So based on this matrix, if I tell you that there is one polar, one charge, one hydrophobic amino acid, which amino acid is the hydrophobic amino acid? Can you deduce it from this matrix?
Is it 2?
Amino acid is A, B, Z. Which one is the hydrophobic amino acid?
Oh, okay, sorry.
So
A?
A is the hydrophobic one. Why?
Yes, because it's very different than B and Z.
The other two. So
Yes.
it's more different than the other two. When A is positive, the others are negative. When A is negative, the others are positive. So here A is the hydrophobic amino acid. And which one is the polar amino acid?
Z.
No, B. B. Why? The one that's less penalized. So this position prefers hydrophobic amino acid A. The ones that's less penalized when it's present at that position is the polar one, because hydrophobic, very different than polar and charge, but it's most different than charge and less different than polar, because polar is at least neutral. Charge has a charge on top of it. So this similarity from charge is much more than this similarity from polar. So it's the one that's less penalized at the position where A is preferred is the polar one. So B is the polar one and Z is the charged one, according to this. So A is hydrophobic, B is polar, Z is charged. Okay, you can deduce it from this one. So when A is very negative, Z is higher positive and B is less positive. So what can you say about position 3 and 4 of the alignment? Which one of the given ones can be the alignment of position 3 or position 4? When you compare these two, position 3 prefers Z or B, but position 4 prefers Z more because it gives you a higher score and B less. So for that, for sure, I can say that in position 4, Z is more conserved. In position 3, there's less Z's, but in position 4, there is more Z's. So Z is more conserved. So that's why I would say that Z is much more preferred at this position. So most likely, if you have an alignment like this, position 4 will have all the Z's, and position 3 will have some Z's and some B's. It would have some Z's and some B's, so that position 4 gives a very positive score for Z only, and much less positive score for B, and that's the similarity of Z to B. But position 3 prefers both of them, so their scores are almost similar to each other.
In 4, can't we just also still have B, but like maybe one only B?
You can, but there is more Z conservation.
Yes, there is more.
That's one thing that you can deduce out of this.
Yeah.
Okay. So, and these are the kinds of questions that I would ask, and that you can deduce from a given profile matrix. And what's the most significant mutation, most deadly mutation, according to this profile matrix? Most deadly mutation is, that means you are losing your profile. So you're losing your profile. Where do you lose the most of the score when you do a mutation? For example, in position 1, if you mutate B to A, you lose only one score. You go from 0 to -1.
On the 4th position?
On the 4th position, if you change from Z to A, you're losing how many points? 52 points.
Yeah.
Right? So the most deadly mutation here is 4th position, because that's the highest difference between the positive score and the
Negative scores. Let's go.
So most deadly mutation on the fourth position from Z to A. Because you lose a score of 52. You lose 52 points. What's the second most deadly?
Third position, then the second, then the first.
Third and second, actually, both.
Yes.
Third position from A to Z or Z to A mutation, you lose 45 points. And the second position, A to Z mutation, you lose 45 points as well. So these two mutations are equally deadly because in both cases, you lose 45 points. So the most deadly mutation is Z to A mutation. And the second most deadly mutation, there are two, Z to A mutation at position 3 and A to Z mutation at position 2. Okay. So you can rank the mutations, and that's one of the applications of the profile matrix. You can look at the impact of a mutation, whether it's a deadly mutation or not. So if it's a profile, if you have a profile matrix, you know which amino acid is preferred at that position. And if it's an unfavored amino acid, how much it is penalized. So based on this one, you can look at how deadly a mutation is in a person. And you can give an impact score to the level of mutation. So that's why if someone has this sequence, let's say this is the protein sequence, and this profile is the profile of the active site. So you're going to look for all the formers. The first former is ABBB. What's the score for that one? A at position 1, B at position 2, P at position 3, B at position 4. 1, -1, -15, 10, and 6. This has a score of 0. BBBZ has a score of 15. Because B at position 1 is 0, B at position 2 is -15, B at position 3 is 10, and Z at position 4 is 20. So BBZA has a negative score, -32. So this person would carry this activity, but with a score of 15. So it's not very high. At what confidence level are you that you will carry out this activity? So I can tell you that the average of this profile matrix is 30 and standard deviation is 15. So this person, let's say this is the ugrase enzyme. What's my confidence that this person will carry out ugrase enzyme efficiently? So for that, average is 30. The score over here is less than the average, 15. Okay, the person's score is less than the average. So what's your percentile confidence score for this one? Average corresponds to Z is equal to 30. 15 corresponds to Z equal to X minus mu over sigma. So 15 minus 30 over standard deviation 15 minus 1. So this position corresponds to Z equal to -1. And as you know, for the normal distribution, 68% lie within one standard deviation of the mean, and 95% lies within two standard deviations of the mean.
47.5.
Two standard deviation of the mean. So I'm asking you this area. If I have a score of 15, what percentage is below me? So I'm asking you this area. So -1 is here. So this total area is 68%. This is half of it since it is symmetric. So this part is 34%. Okay, and what's this area? 16%. So this person is on 16th percentile. So only 16% of the individuals have a score less than this person. So I'm only 16% confident that this person will carry out the Ugray's activity. Okay. So I'm only 16% confident that this person will carry out, because average score you can obtain from this matrix is 30, standard deviation is 15. So this person's profile score is 15, which is one standard deviation below the average. So at what percentile this person is, at what confidence level this person is going to carry out this activity, is this area, the area underneath, which is, since this is -1, the area between -1 and +1 is 68, and this is half of it, 34. So this area is 50 minus 34, 16%. So I'm only 16% confident that this person will carry out this activity. Even though it is weak, it will carry out this activity.
Sir, what if, for example, you told us how can we make, for example, ABB become have like a high score? Can you replace it with Z?
I will ask questions like that right now.
Oh, okay.
So, at what mutation is the deadliest mutation for this person? That you lose Ugray's activity, and when you lose Ugray's activity, you get bad bioinformatics disease. So, what's the deadliest mutation for this person so that this person loses the Ugray's activity? So, where do you get this 15 from? B at position 1 gives you 0. B at position 2 gives you -15. B at position 3 gives you 10. And Z at position 4 gives you a score of 20. But if you change the Z to an A, what happens? If you change this position to an A, then this becomes BBBA. BBBA has a negative score. And the last former becomes BBAA. BBAA also has a negative score, and this person cannot carry out this activity. So if there is a single mutation, the deadliest mutation this person can have is the mutation at position 1, 2, 3, 4, 5 from Z to A. Then it will cease carrying out the Ugray's activity, and since it's not going to carry out the Ugray's activity, this person will most likely to have bad bioinformatics disease. Okay. Is there a mutation? Which mutation will enhance this person's Ugray's activity the most? Okay, for that one, what you can do is this: ABBB. A at position 1 is -1, B at position 2 is -15, B at position 3 is 10, and B at position 4 is 16. So you can change this B from B to A. In that case, you have AABB, and AABB, A at position 1 is -1, B is 20, 19, BB is 16, 35. So if you mutate this B to A, you get a score of 35. Then, what happens to this one? This becomes ABBZ. A at position 1 is -1, BBZ. That lowers you this score, ABBZ, from 15 to ABBZ to 14. It lowers your score of this one from 15 to 14. But this part, AABB, you'll have a score of 35. So you increase your score 15 to 35 through this mutation. Is there any other mutation that I can enhance the score? BBBZ I had, and B at position 2 is -15. So I can change this B to an A. So if I change this B to an A, and in that case, my score becomes BABZ, my sequence becomes BABZ, And what's the score of that one? B at position 1 is 0. A at position 2 is 20. B at position 3 is 10. And B at position 4 is 6. So 36, your score increases to 36, which is better than 35. So this is a more impactful mutation. Mutation at third position from B to A. And how did I decide on this mutation? This one is the second position of this one. So second position was minus 15. And if you change that to 20, you have an increase of score of 15 points, 35 points. So it will enhance your score by 35 points. So you are gonna have a better score from this one. Or BBZA, BBZA, instead of A, I can change the last position to a Z. And in that case, I have BBZZ. What's the score of BBZZ? BBZZ has a score of 20. That doesn't improve it to more than 36. So the best mutation is at position 3, from B to A. And that mutation will enhance my total profile score to, if you have B to A, BA, BB, BZ, BA, BZ. Oh, sorry, that has a score of 50. That gives me a score of 50. So that's the highest impact enhancing score mutation, mutating third position B to A. That will increase my score by 35 points. Okay, so I can ask questions like this from the given profile matrix and from a given sequence and so on. What's the deadliest mutation that will seize the uberase activity? What's the mutation that will enhance the uberase activity the highest? And if I have someone with this one, A, C, A, well, no, I don't want that, B, A, E, A, minus 55, 55 also istemiyorum. İstemiyorum. 35, 41. Skorları tam doğru vermemişim. So what should be your profile score that so that you are 84% confident of uberase activity? So which motifs you should have so that you are at least 84% confident of uberase activity? So to be 84% confident, that means this area under you is 84%. So your score is at such a level that all the scores under you is 84% of all possible scores. So that means you are 34% above the mean. And when you are 34% above the mean, then you are one standard deviation above. Okay, then that's when you are 34% above the mean. So that means your score should be one standard deviation above the mean. And your average score is 30, plus one standard deviation is 15. So you should have a profile score of 45 or higher to be 84% confident of uberase activity. So how can you get a profile score of 45? The second position has to be A.
And
The third
position
position
Z?
can be B or Z. And the fourth position can be B or Z. So out of these ones, which one gives you 45? If this is 20, B or Z, 10, 15. So if this is B, this has to be Z to increase it more than. So if you have A at position 2, and B at position 3, then the position 4 has to be Z. Because A 20, B 30, to increase it over 45, here between B and Z, you have to have Z. So the second position should be A, third position B, and the last position Z, and the first position can be anything. Because it's only -1, 0 or 1. Anything, A, B, or Z, either one of them. But if the third position is a B, a Z, if the third position is a Z, then you have a score of 35. To make it over 45, again, the last position should be Z. So you have to have last position Z, always. So the second position has to be A, last position has to be Z, third position can be B or Z, and the first position can be any one of these. So I can ask you, which of the given profiles you should have to be at least 84% confidence? And I can say A, B, A, C, X, C, A, C, A, B, D, A, B, Z, E, none of the others. So here it has to fit into these motifs. A at second position and Z at the fourth position. And only this has A at second position and Z at first last position. And the third position should be B or Z. And the first position doesn't count. So if you have this motif, your profile score is over 45 and you are 84% confident. So I can ask you which one of the given motifs you should have that you are at least 34%, 84% confident of Ugray's activity. So these are the types of questions I can ask from profiles. You should be able to interpret these and answer these questions. There will be around 8 or 9 questions out of 50. So it's going to be like 20% of your score. So you have to know this subject very well. Okay. And what else I can ask from profiles? Any questions on these?
Yeah, how did you get 30 or 15?
What?
How did you get 30 or 15? And how did you
I
determine?
gave you 30 and 15. Average score of this profile matrix is 30, and standard deviation of this profile matrix is 15. It's given.
Okay, so how do we do you also give us the 84% confidence with work it out, or?
I ask you that what motifs you should look for at 84% confidence.
Okay, thank
I
you.
gave you that. That's part of the question. But you should know that 1%, according to the normal distribution, if you are within one standard deviation around the mean, this is 68%. And if you are 2 standard deviations of the mean, this area is 95%. That you should know. Okay.
Sir, how did you know it's what is it called? 2 points away from the 30 and 15?
What?
How did you know that it's 95%? I mean, it's not 1, because I think from 15 and 30 it's only 1. Why did we say 2?
We didn't say 2. Who said 2?
I mean, is it 1 or 2? Like, they deviated from the normal distribution.
If you are only 1 standard deviation away, it's 1.
Yeah.
If you are standard deviation away, it is 2.
And here it's 1, not 2, right?
This is 1. I'm always saying 1, minus 1. See?
Okay. Also, sir, could you solve a question like last time when you gave us like different students with different scores and we said, oh, do they have a disease or not? Bioinformatics disease or something.
Okay. Let's give the Ugray's matrix. This is the profile matrix for ugrase enzyme. Okay, I'm gonna give you Ali, Veli, Mehmet, Ayşe. This is the sequence for Ali. This is the sequence for Veli. This is the sequence for Ayşe, Mehmet, and this is the sequence for Ayşe. Which student will perform the best in bioinformatics? If you have superior ugrase activity, you will do good in bioinformatics. Which student will do the best in bioinformatics? So you're going to find all the former sequences. XXBB, XXBB has a score of 25 plus 18, 43. XBBB, XBBB has a score of 38, 36. So most likely 43. This has a score of 43. XXBZ, XXBZ has a score of 43, 58. XBZB, XBZB, XBZB has a score of 48. XBZB, XBZB has a score of 48. So here the score is 58. XABB, there's A. Oh, there's no A. Okay, let's change this to Z. XZBB, XZBB has a score of 33. ZBBB, ZBBB has a negative score. So this has a score of 33. ZXBB, ZXBB has a score of 3. XBBB, XBBB has a score of
36.
So which one has the lowest score? Mehmet. Which one has the highest score? Veli. So if the bioinformatics performance depends on the ugrase activity, Veli will perform the best, and then Ali, then Ayşe, and the weakest one is Mehmet. Okay. Is there a single point mutation that can cause Ali to have bad bioinformatics disease? So that means through a single mutation. So which mutation is most likely to cause Ali to have bad bioinformatics disease?
Maybe if the first position is Z, perhaps?
No, but you still have XBBB. If you change that position, you still have XBBB.
X in the third position. Because it's negative 30. So
Yes, the score of 36, Ali cannot have bad bioinformatics disease. It's weaker, but it cannot. So it shouldn't be the first position. It should be either these positions. This is the second position of the first one, but the second position is not important.
yeah, the third position, it has the highest,
The
negative
third
30.
position is E, but you can change that to NX. So
Yes.
to XX, XBB, that could be one alternative. From B to X, you are losing 38 points. So if that's the case, XXXB has a score of XXXB has a score of 5. So XXBB is still positive. So this mutation is not okay either. So it shouldn't be this position. Maybe the last position. The last position, if you change from B to X, that could be the disease-causing mutation, XXBXB. If you change your sequence to this one, XXBXB, here XXBX, XXBX, still positive. 33, this has a score of 13. XB, XB, XB, XB is a negative score. But still you have a positive score. So there is no single mutation that can cause Ali to have a bad bioinformatics disease because you always get a positive score. So he's still carrying out the Ugray's activity. I will give you several mutations, and the last one is there is no single mutation that can cause Ali to have bad bioinformatics disease, and that's the answer. Okay. What about Veli? Is there a single mutation that can cause Veli to have bad bioinformatics disease? XXBZB. This has a score of 58, and this has a score of 48. I want both of them to be a negative score.
Professor, it's XXBZ, right? So XXBZ is 48, not 58,
XX
right? 48.
BZ 25,
25 plus
40, 48. Yes, this is 48. So XXBZ, XBZB, XBZB. That's 48 as well. So is there a single mutation that you can go from 48 to a negative value? The highest one is this, minus 30 to 20. That's the highest one. So changing this position from Z to an X. Here you have XXBX, XXBX is still positive. So there's no mutation for VD to have bad bioinformatics disease. So I can ask you things like that. Is there a single mutation? But here for Aisha, yes. CXBBB, is there a single mutation that can cause Aisha to have bad bioinformatics disease? This has a score of 3. This has a score of 36. So you have to lower this 36 to a negative score while you are having a negative score for this one. So in the third position, you can go from B to X. If you go from B to X into the third position, this becomes XB, XB, XB, XB is a negative score. Minus 32 plus 30 is a negative score. So this becomes minus 2. CXBX, CXDX is a negative score as well. So through this mutation, B to X mutation at the fourth position, Aisha cannot perform Ugray's activity and Aisha will have bad bioinformatics disease.
Sir, I have a question.
Yes.
If Aisha, for example, had a score of negative 36 and positive 3, and Mehmet had negative 4 and 33, does that mean that Aisha has the disease but Mehmet doesn't?
You look at the highest positive score. And as long as you have a positive score, you are still carrying out this activity, even though weakly. Like the other guy has only 16% activity.
So,
But even weak activity will prevent you from the disease.
so Aisha will still carry it out even if it was only positive 3 and negative 36.
Yes.
Okay.
So only way to have the disease is not having a positive score. If you have a score of 0 or negative, that means you have a disease.
Okay. Thank you.
Okay. And one more thing that I can ask you, the matrix. I can give you the matrix and the alignment. Okay, I can tell you that this is the first position of the alignment and this is the second position of the alignment. Okay, and score for A at position 1 is 6 and score for B at position 2 is 12. Which one of the given ones is true? So, 1 second. BB similarity is 8. AA similarity is 3. DB similarity is 5. AA similarity is 9. Cannot be determined. None of the others. So from this information, if A at position 1 is 6, that means 2AA plus 2AB over 4 is equal to 6, right? A at position 1 is 2AA plus 2AB over 4 is equal to 6. B at position 2 is 12. So that means AB plus 3BB over 4 is equal to 12. So from here you know that 2AA plus 2AB is equal to 24. AA plus AB is equal to 12. Okay. So, and here AB plus 3BB is equal to 48. But from here you cannot find AA, you cannot find AB, you cannot find DB from this given information. So the answer is cannot be determined from the given information, AA or B. But I can ask you which of the given equations are correct. And I can tell you that AA minus 3BB is equal to 36. B, 3BB minus AA is equal to 36. C, 2BB minus AA is equal to 24. D, AA plus BB is equal to 12. E, none of the others. So here, from this given two information, you can subtract this from this one. AB's cancel. You end up with 3BB minus AA equal to 36. So 3BB minus AA equal to 36. From the given information, which one of the given relationships are correct? You write two equations, and then you subtract the AB's, and you find that 3BB minus AA should be equal to 36. Okay, I can ask you this one, or which one of the given similarity scores would satisfy this condition? So I can say BB similarity equal to 15, for example, and AA similarity equal to 9. Because it has to give you 36. 3 times 15 minus 9 is equal to 36. So BB can be 15, AA can be 9. So I can give you these kind of questions. Which one of similarity scores would give you such a profile matrix? Okay, BB equal to 15, because you know that 3BB minus AA should be equal to 36. If BB is 15, then AA has to be 9. 45 minus 9 is equal to 36. So I can give you BB 10, AA 3, BB 0, AA minus 5. And you have to choose BB 15, AA 9 as the answer. Okay.
Sir, how did you find the 24? 2AA plus 2AB is equal to 24.
A at position 1 is 6.
Yes.
So how do you calculate A at position 1?
We have 2 AAs and then
AA plus 2AB
two.
over 4, since I'm aligning 4 sequences,
Yeah.
should be equal to
6.
Okay.
Mm-hmm.
How do you find this score? B at position 2 is 12.
AB plus 3BB over 4.
AB plus 3BB over 4 is equal to 12. So if you write this one, 2AA plus 2AB equal to 24. Right? If you bring
Okay. Okay.
and
Mhm.
plus 3BB equal to 48. And here you subtract them. 3BB minus AA is equal to 36. Okay.
Okay. Yes. Thank you. I understand.
These are the types of things that I would ask from the profile matrix.
Fair.
How do we get minus AA? Like, why is it minus?
Which one is minus AA?
It says, yeah, why is that minus?
Okay.
We're
This
gonna
equation
subtract.
tells me that 2AA plus 2AB equal to 24, right? This equation. This equation tells me that AB plus 3BB is equal to 48. I multiply 4 with 12. Okay. Now I want to cancel. Here I can divide everything by 2. So I end up with AA plus AB equal to 12. Correct? So I have these two equations. How can I cancel AB? I subtract this from this one. So if I multiply this with minus 1 and add these two, AB's will cancel. Plus AB minus AB. AB's will cancel. I will have minus AA plus 3BB is equal to 48 minus 12, which is 36. So that means 3BB minus AA should be equal to 36. Because I canceled out AB's to find the relationship between BB and AA. Okay? That's why it's minus. I subtracted this from this one. Any other questions?
No, it's pretty clear. Thank you, sir.
Okay, the final is cumulative. So it's going to be everything. And it's going to have beginning part will be around 30% of the questions from the first midterm, the one that first midterm subjects will be around 35%, and 65% will be the things after the final, after the midterm.
So like 20 questions from the midterm almost?
Yes, 20 questions from the midterms, maybe 18 questions from the midterms, maximum, and 32 questions from the things afterwards. And out of those 32, 9 will be from these ones. So you will have lots of questions like this as well. If I give you the fragments, A, C, G, A, C, G, G, A, C, C, and T, G, G, A, C, and A, C, C, C, C, A. So I give you 5 fragments. If you combine these 5 fragments using T equal to 3 and error rate equal to 0, how many context solutions do you get? So I want minimum 3 letter overlaps between them without any error. How many? So sequence 1, sequence 2, sequence 3, sequence 4, sequence 5. You write the
Without
sequences.
3, minimum 3.
1 and 2, do they overlap with 3 letters without any errors? No. This ends with AAA, this ACG, this starts with AAA? No. 1 and 3? No. 1 and 4? No. 1 and 5? No. So 1 is not connected to any one of them. 2 and 1? TGG? No. 2 and 3? No. 2 and 4? Yes. 2 to 4, you have 3 letter overlap. So you are going with 3 letters. 2 and 5? No. 3 and 1, ACC, AAAC, AAAC, AACC, no. 3 and 2, no. 3 and 4, no. 3 and 5, no. 4 and 1, no. GAC, AAA. 4 and 2, no. 4 and 3, no. 4 and 5, no. 5 and 1, AA, not, but they are not overlapping with 3 letters. I want minimum 3 letter overlap. 5 and 2, no. 5 and 3, no. 5 and 4, no. So only 2 and 5 is coming together. That forms a single contig. And these 3 alone by themselves, so you end up with 4 contig solution. And your solution is AAA, TGG, TGG-AC. So when you bring them together, your contig is AAA, TGG-AC. So these two comes together. This is alone by itself, AAACG alone, AAACC alone, and this is CCAA alone. So I have 4 contig solution. Contig 1 is this, contig 2 is this, contig 3 is this, contig 4 is this. What if I ask you t equal to 2, error 0? Now I'm going to allow for 2 letter overlaps. So from 1 to 2, there is no 2 letter overlap without any error. But 2 to 1, TGG, no. 2 to 3, 2 to 5, you have 3 letter overlap. 2 to 3, no. 2 to 5, no. 3 to 1, AACC, AAAC, no. 3 to 2, no. 3 to 4, no. But 3 to 5, yes. This ends with CC, this starts with CC. So 3 to 5, we have 2 letter overlap. 3 to 5. Oh, this is wrong. This is 2 to 4. Two to 4, 3 letter overlap. 3 to 5, 2 letter overlap. And 4 to 1, 2 letter overlap, no. 4 to 2, 2 letter overlap, no. 4 to 3, no. 4 to 5, no. 5 to 1, 2 letter overlap, yes. And 5 to 1, AA, it's overlapping. 5 to 2, 2 letter overlap, yes. AA. 5 to 3, 2 letter overlap, yes. So here you get 2 to 4, 1 contig, 5 to 2, another contig, 3 to 5, another contig. So if you look at the solution, you can go from 3 to 5, 5 to 2, 2 to 4. 3 to 5, you have 2 contig solution. 5 to 2, you have 2 contig solution, 2 overlap solution. 2 to 4, you have 3 overlap solution. And 1 is alone by itself. That's the longest one. So you end up with, in the best solution, minimum 2 contig solution in this case. 1 is alone by itself. 3, 5, 2, 4. So 3 first, AAA, CC. And then 5, CCAA. And then 2, AAA, TG. And then TGG, sorry. And then TGG, AC. So when they come together, AAA, CC, AA, ATGGG, AC. This is 1 contig, and the second contig is 1 alone, AAACG. So there will be 4 or 5 questions on these kind of things as well. So what's the most likely consensus sequence? How many contig solutions do you get? And so on. What happens if I increase this error rate to 0.2? How many contig solutions do you get? Which one is the given one? So these are the types of questions from the fragment assembly. And then you will have questions from the phylogenetic trees. I'll give you the character state matrix. Does it follow perfect phylogeny? Do you get perfect speciation? What which mutation from 0 to 1, change from 0 to 1 will give you a tree with perfect phylogeny but no perfect speciation and stuff like that. So you will have 2-3 questions from those. From the distance matrices, how to get the mean, max, average methods and stuff. There are some questions from those. And then profile matrices, right? After the midterm, we did fragment assembly, we did phylogenetic trees and added trees. And then we did the profiles, right? We didn't do everything else after that.
Yes.
So out of these, you're gonna get like almost 32 questions from these subjects.
Mm-hmm. Sir, are there a lot of seed list questions?
There are some blast questions, like 3-4 questions from the blast, 2-3 questions from the FASTA.
Seed list.
Seed list is blast.
Yeah. 3 to 4 questions. Oh, okay.
Okay.
Mm-hmm.
So that's the general concepts for the midterm.
Mhm.
Let's go over your project. In the project, we give you the virus sequence. Let's say this is the sequence. We give you a bacteria sequence. Let's say this is the sequence. And we give you a mammalian sequence. Let's say this is the sequence. So, if you look at it, I want you to write a code to write 2-letter words. So you have AA. How many AAs do you have? 1, 2, and 3. You have 3 AAs. How many ACs do you have? Only 1 AC. How many CA do you have? 1 CA. And the rest is 1, 2, 3 CC. That's your composition. So in your composition, you have 3/8 CC, and 1/8 CA, 1/8 AC, 3/8 AA. Bacteria, you do the same. So this many TTs, but bacteria has lots of TT. 1, 2, 3 TTs, and the mammalian has lots of GGs. 1, 2, 3 GG. So is the bacterial viral sequence AA composition is different than the bacteria AA composition and mammalian AA composition due to hypothesis testing, and you find that AA only belongs to the virus, and it's very significant, the hypothesis testing. And bacteria has TT in abundance, mammalian has GG in abundance. So I give you a sequence like this. So, which sequence this one belongs to? So, when you identify the motif ones, which 2-letter words are in abundance in viruses and bacteria and stuff like that, then you look for your composition. This one has 1, 2, 3, 4 CC, 1, 2 AA, and 1 AG, and 1 CA. So 6, 8, 2/8 AA composition. So 25% AA. Do you have 25% AA in bacteria? No. Do you have 25% AA in mammalian? No. Do you have almost 25% in virus? Yes. So in terms of this, it's closest to the virus sequence. So most likely this is the virus sequence, but you're going to do it for every. So there might be other frequently occurring 2-letter words in virus. So you're going to find all of them. So AA is mostly seen in virus, but not in bacteria and mammalian. For example, CA, AC is mostly occurring in virus, but not others. For for example. So these are the motifs for virus, AA and CA. And TT only occurs in bacteria, CT only occurs in bacteria, TC only occurs in bacteria, GG only occurs in mammalian. So you find the important two-letter words by doing pairwise hypothesis testing. So you find the motif two-letter words for viruses, bacteria, and for the given sequence, this sequence has 3 viral motifs, 1 bacterial motif, and 1 mammalian motif. Since the majority is the viral motif, this sequence belongs to virus. If the majority is bacterial motif, this sequence belongs to bacteria. That's what I want you to write as a code. And you're going to do these motifs as a 2-letter word and a 3-letter word as well. And based on number of motifs that the query sequence has, you're going to assign it to a class. Okay, that's your project. And you should write this code until 21st of June. And then we will send you a test sequence and you're gonna send us your code and your result. That this is a virus sequence because it has 3 out of 8 viral motifs. It has 1 out of 8 bacterial motifs. It has 1 out of 10 mammalian motifs. So that's why, since the abundant is the viral motifs, this sequence belongs to a viral sequence. So I want you to write a code like that. Okay.
Okay, sir, could you maybe extend it like a day extra, because on the 22 we're gonna be having our exam, so it would be better maybe on the 23rd, if it's possible with
Let
you.
it be the last date of sending the marks. I think 22
Ah,
last date. So if
okay.
you send us the results on 23rd, we may not have enough time to grade them.
Okay.
Let me
Also, yeah.
the last date of grade submission. If it is 26th or so,
Mm-hmm.
then you can send it on 23rd. But if it is 23rd is the last day,
Okay.
then you have to send it on 22nd.
Okay. Okay, sir. Also, sir, lastly, could we please use calculators in our finals at least, because it would save us a lot of time. It was a bit tough during midterm.
What do you mean by calculator?
Like our calculators, like Casio calculators.
There was no need for that in the midterm.
Can we use it in finals?
Was there a need for calculator?
Yeah, like for the scores or something. It's like faster.
Adding the plus minus
Or
value?
multiplying or stuff. Yeah,
Oh,
just in case.
No,
Okay.
no, that shouldn't be the case.
Okay.
Because with the calculator, if you are using the phone,
Not
you cannot.
not phone. Our calculators, like Casio calculators.
Not everyone has Casio calculator though. So most people will want to use their phone, and when you are writing something to the phone, we don't know whether you are typing someone a message or not.
Okay.
Okay.
Mm-hmm.
There will be 2 questions on the devices scheme so that you get 1,000 long fragments type of things. For those you need calculators, but you can do it easily on your own.
But what?
Device
Mm-hmm.
scheme using restriction enzymes
Yeah.
to cut 100,000 long DNA into 700 long pieces. So I will use 3 6-mers and 4 8-mers.
Yeah.
This type. Here you do need something. Okay.
Mm-hmm.
But that you can easily do it by hand. Only 1 or 2 questions. I'm giving you plenty of time to solve these questions, so you can do 2 on your own without a calculator.
Okay.
Okay.
Mm-hmm.
Okay. See you on 21st. We will have the review, and I will send you 2 final exams of the last 2 years. Okay.
Okay. Thank you.
Bye bye.
Bye.
Take care. See you.